Okay, exercise 6G, page 410, volume of pyramids and cones, 4C. Base of our face triangle is 5, height of our triangle is 5, height of our pyramid is 12. We could probably get a little bit clever there with some maths, but let's not be too exciting. 0.5 times 25 times 12, and then just divide by 3 is the quickest way of doing that third. Yeah, we could have been a bit clever. We're in kilometres, it's volume, it's cubed. Question F. We have an oblique square-based pyramid. Still 1/3 area times height. Oh, it's rectangular. Length times width. And the perpendicular height is listed down the bottom there, which is very helpful. If you're wondering why I'm dividing by 3, it's just the easier way of getting 1/3. Okay, question 5, cones. They've given me the diagram, I don't need to draw it. 1/3 area times height, rewrite that as 1/3 pi r squared times height. Ah, 20 metre radius, 60 metre height. Two decimal places. Meters cubed. Notice we get quite a large volume, especially with anything involved with a circle. It's often surprisingly large. Front of F is another oblique shape. It's an oblique cone, still the same formula. Radius is 20 divided by 2, which is 10. We're in centimetres. And rewrite your formula. Oops, I've got off the page. 1/3 pi times 10 squared. And the height is 5. Well, that'd be 500, so 500 pi divided by 3. We had 0.598, so be careful with your rounding there. Centimetres cubed. Question 6. A medicine cup is in the shape of a cone. They haven't given me a diagram, we better draw one. You don't need to add the cute little thing that it stands on here, just draw the cone. Radius of 3 centimetres, height of 5 centimetres. Capacity in millilitres means we start by finding the volume in centimetres cubed. Oops, 1/3 AH. I am okay, of course, with you starting with this formula here. That's 45 pi divided by 3. Have a look at the little shortcut that happens there. You don't have to do that. Yeah. 47.12 centimetres cubed. Now we want the volume in mils, correct to the nearest milliliter, and they equate, so that's volume or capacity is 47 millilitres. Composite solids, question 7. Let's do C. I have a square-based pyramid and a rectangular prism. So I'm just combining the formulas. It's a rectangular based pyramid, let's see. So that's 6 by 3 for the area. The height is 4 minus 2, which is 2. There we go, that's a little tricky. And then length times width times height. It's 12 plus 6 times 6 is 36, 48 meters cubed. That's our volume. You might find E a little tricky because we have 2 identical square-based pyramids, and it looks like we're going to have to find no, we're okay. So volume is 2 times 1/3 AH for these square-based pyramids. Well, that's 2/3 times the area of the square is 2.8 squared times the height. Now let's just work that out separately over there. Is 3.96 divided by 2. .98. That's because the two shapes are put together there. So it's 1.98 times 2.8 squared times 2 divided by 3, 10.35 meters cubed. Question 8. Looks like a truncated cone. Okay, now they gave me a diagram, but I'm just going to draw one. Okay, the volume of ice cream in the cone is half the volume of the cone. And I've got everything I need for the volume of the cone. So I'll find the volume of the cone of ice cream and then find the depth. Volume is 1/3 by our squared height. Oops. Now I might just keep 42 pi there because I've got to do some more calculations with that. So that's my large cone, and the volume of the small cone is half that. And I want to find the depth. So volume is 1/3 area times height. So that volume, as I said, was 21 pi, 1/3 pi r squared height, multiplied by 3, 63 pi. Well, let's just divide by pi on both sides as well, is r squared height. Now, what have I missed about the radius? Okay, I had to stop and think for a second there. But the length relationship, did I not need to work that out? That would be embarrassing. Length relationship is depth to 14. No, volume relationship is half. Small to large, volume is 1 to 2. So length is 1 to cube root of 2. I don't know how you guys are going to do this. I know how to do it, I think. So the radius was 3, so 1. So it's 3 times cube root of 2. Gosh. Not sure I'm right here. 63 equals 3 times the cube root of 2 squared times height. 63 divided by 3 times the cube root of 2 squared times height. Cube root of 2. Well, if my height is 4.41 centimeters, that's the depth of the ice cream, and I'm going to go check that because that was a bit tricky. How you do that without the knowledge of the length and volume ratios, I'm not certain. I'll have to look that up.